All right, so welcome to the review of the last test. Remember, this is for the test retake that will be during class on Wednesday on November 6th. So let's start right away. Most of this stuff we might actually do without the calculator. So the biggest chunk of this will be looking at the different parts of the polynomial function and try to figure stuff out. So for this one, number 1 and 2, we have to figure out the end behavior. What we said in class, we could try to figure this out using some parts of our function. So we need the degree and the leading coefficient, just information about that. So if we said it was even and positive, it would act like a positive parabola. If it was even but negative, it would act like an upside down parabola. If it was positive and odd, it would act like a positive sloped line. If it was negative leading coefficient and odd, it would act like a negative sloped line. So that means as x goes to infinity, aka the right, y would go to infinity. As x goes to negative infinity, then y will go to positive infinity. For even functions, it's symmetrical, so then behavior has to be exactly the same. So that means as x goes to infinity, for this case, y goes to negative infinity because it's facing down. As x goes to negative infinity, y goes to, just like the other one did, negative infinity. So that's even functions. For odd degree functions, as we go to the right, our function will also go up. So positive infinity for x, positive infinity for y. As x goes to negative infinity, y will go to negative infinity. We could always just graph these and zoom out enough to see what happens. But we could also do this with these kind of other ways. As x goes to the right, if we had an odd function that had a negative leading coefficient, our y will go down. As x goes to the left, our y will go up. So let's try to use this in practice. For number 1, we're just looking at this term here. Our degree is 4, so that means it's even. And our leading coefficient is -1, which means it's negative. So using our table here, that means we have an even function, negative leading coefficient. So we're going to have this upside down parabola type of shape. So that means we're looking for something as it goes to the right. Right, as it goes to the right, we go to negative infinity. So this is incorrect, this is correct, this is correct, this is incorrect. Next, as we go to the left, we want to go down. So we want negative infinity. Why did I circle that one? Right? But this one is the only one that goes down, this one doesn't. So that means the only answer that we could have is C. Looking at number 2, we have a degree of 5 and a leading coefficient of +1. So that means we are now looking over at this one. So that means we want, as we go to the right, which is all of these, we want to go to positive infinity. So this is an option, this is not, but this is. So now we're deciding between A and D. As we go to the left, we want to go down. So that's why D is the correct answer. Number 3 and 4, we're also just using the function. We don't have to graph this. We want the maximum number of turning points. The maximum number of turning points is just the degree -1. So we're just looking at that highest degree term to find our degree of the polynomial. So we're doing 2 minus 1 here to get b, and then 4 minus 1 here to get 3. For number 5 and 6, we want the possible number of real zeros, aka the max zeros, which is just equal to the degree. So I kind of walked around class and talked about this. We don't really care about the other stuff. We want the max. So here the degree is 4, so the correct answer was A. Here the degree was 3, so the correct answer was C. For numbers 7 through 10, we had to factor or solve. All right, there's different ways to look at this. If we look at number 7, we want to see, can we take something out of everything? And yes, we can. We can take x. And then we're trying to always do the least amount of work, and I think the quadratic formula is just so much work. So we want to see, does anything multiply up to 5 that adds up to 6? And yes, we get x plus 1 and x plus 5. We multiply up to 5, add up to 6. So that is our factors. And we set everything equal to 0. And so this would give us x equals -1, and then x plus 5 equals 0. So x is equal to -5. So that means our answer is A. Next one, we tried the same method. Can't. So the next method is always to try to group it. So we can take x squared out of the first two terms. We can take a -2 out of the first two terms, and be careful, -4 divided by -2 is +2. And we do get the same factor here. So we get x squared minus 2 inside the parentheses and x plus 2 inside the parentheses. So then we always just set them equal to 0. So we get x squared equals +2. So if we take the square root of both sides, we get x is equal to positive or negative square root 2. And over here, we just subtract 2 on both sides. So we get x is equal to -2. So we could have ruled out d right away, and then we wanted just square root 2 and negative square root 2. So our correct answer is B. If we look at 9, we can take an x out of everything. And now we're looking for two numbers that multiply up to -6 but add up to -4. We won't ever get our answer. So that means we have to use the quadratic formula. But we can do the first part first. X equals 0. So right, that's where we get all these zeros from. And now we can set just the quadratic part equal to 0. So we can plug it in. Remember, we had those mostly two ways to remember a quadratic formula. First, the story. So that was, there once was a negative boy who couldn't decide to go to the radical party. The boy was square, so he missed out on 4 awesome chicks and was all over by 2 a.m. So now let's plug it in. B is negative, so it turns into +4 plus or minus -4 squared minus 4 times 1 times -6 all over by 2 times 1. So 4 plus or minus 16 plus 24 all over by 2. 4 plus or minus 16 plus 24 is 40 all over by 2. We can take some stuff out of the square root, so we get 4 plus or minus 2 square root 10 over 2. And then we can do that division to get 2 plus or minus the square root of 10. So we have our 0, and then 2 plus or minus the square root of 10. So the answer is C. Again, let's look at 10. Try to do the simplest things first, which we can try to factor out this x from everything. So we get x times x squared plus 4x plus 13 equals 0. So we will still get x equals 0 first. And again, that's in everything, so it doesn't help us out too much. And then we have our quadratic. So the other way to memorize our quadratic formula was that song, which was the following. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. So that means x is equal to x is equal to -b plus or minus the square root of 4 squared minus 4 113 all over by 2 1. So -4 plus or minus 16, and here we're going to get some kind of big number, 52 all over 2. So -4 plus -4 plus or minus 16 minus 52 is -36 all over by 2. So we get -4 plus or minus, and that will give us 6i all over by 2. And then we can simplify that 2 out. So So we get negative 2 plus or minus 3i. So remember, we have that 0 here, and then these two zeros here, negative 2 plus 3i and negative 2 minus 3i. So the correct answer is B. Next one, number 11 and 12. We have to use our rational root theorem, which again is take the last term, find all of its factors, and then divide it by all the factors of the first term, which is just 1. So that way we just get plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. So that's how we get B. 12 is a little bit harder. We have an actual value for the first term here. So we have to do all the factors of 22. So we get 1, 2, 11, and 22, divided by all the factors of 3, which is just 1 and 3. So we do 1 divided by 1, which is 1, but we can make that plus or minus. 2 divided by 1, which is 2. 11 divided by 1, which is 11. 22 divided by 1, which is 22. And then we do the same thing, but divide by the next factor. So 1 divided by 3, 1/3. 2 divided by 3, 2/3. 11 divided by 3, 11/3. 22 divided by 3, 22/3. So the correct answer would be D. All right. So moving on to the next idea here. So for number 13 and 14, we want to find all the factors. We could use the rational root theorem to make the list, or we could graph it to figure out our guesses, and we'll be left with one fraction that we kind of have to guess on, or continue with some synthetic division. So let's graph this real quick to see what our options are. So we have we have 2x to the 4th. Three x cubed minus 8x squared plus 3x. So we can look at this and we can see that we for sure cross that negative 3, 0, and 1. So negative 3, 0, and 1, and then some fractions somewhere in between 0 and 1. So we're going to start off, I gave you one, so we can start off with some synthetic division first. All right, and with synthetic division, we copy down the first number and then multiply and then add. We always want that 0. So we did negative 3, 0's next. All right, so 0, copy down the 2. 2 times 0 is 0. Negative 3 times 0 is 1 times 0, 0. So that one was just kind of a silly one, but we can move on. Copy down the 2, we get 2 over here, add them together, negative 1, we get 0. So here that means we get we get 2x minus 1 equals 0. So we get 2x is equal to 1, so x is equal to 1/2. So that's our answer right there. Likewise, if we come over here, I give you one, and we can graph this real quick to see what it looks like. So we have 5x to the 4th. Plus 11x to the 3rd minus 3x squared minus 11x minus 2. So if we look at this, it clearly crosses the x-axis at negative 2, negative 1, and positive 1. And then somewhere in between 0 and negative 1. So I said negative 2, negative 1, positive 1, and some other fraction. So let's start off the synthetic division. We have 5, 11, negative 3, negative 11, negative 2. We copy down the 5, and we just go through this process again. All right. Try the next one that we could clearly see from the graph. We get another 0, perfect. And the next one. All right, so that means we have 5x plus 1 equals 0. So 5x equals negative 1. So x equals negative 1 over 5. So again, that's how we get our answer. For number 15, we're kind of doing the opposite. We have the zeros, and now we want to write our factored form. So to go backwards, what we need to do to remember is this x actually turns into x minus 4. We actually change the sign. The negative 1 would turn into positive 1. The negative 2 would turn into positive 2. But we don't have any equations in factored form. We have them in standard form. So we need to multiply this all together. We can only do it 2 polynomials at a time. So let's just deal with these. We're going to use FOIL. So we get x squared, because that's the first. Outer is plus 2x. The inner is plus 1x. The last is plus 2. So let's clean that up. X minus 4. And that's x squared plus 3x plus 2. And then we just have to distribute. I like showing those arrows. So we get x cubed plus 3x squared plus 2x. And then another set of arrows. And I like to line stuff up. So minus 4x squared minus 12x minus 8. So then we combine like terms. X cubed minus 1x squared minus 10x minus 8. And then there's our answer right there. If we look over at 16, looks like we lucked out because we only have 2 zeros, but we are incorrect because we have a complex number, which means we also have its conjugate, which means we need to change that operation that's on the inside. So we're going to deal with these two first. So we have x minus negative 5, x minus 1 plus I, and then x minus 1 minus I. We're going to do this. We don't have a FOIL, so we have to use our distribution. So we have x times x, x times negative 1, x times I. All right, I'm going to switch colors so we can keep it focused. Negative 1 times x. Negative 1 times negative 1. And I don't have anything to match it up with, so I just move it further to the right. Negative 1 times I would be positive I. And then the last one, we have I times x, which is positive ix. We have I times negative 1, so minus I, and then we have positive I times negative I, so minus I squared. So we're going to try to add these all together. We get x squared, nothing to combine with it. We have negative x plus negative x, so negative 2x. We have a negative ix and a positive ix, so those cancel out. And then that's the same thing happens with the i's. And we need to remember one last thing is that I squared is the same thing as negative 1. So this is just equal to 1. So then 1 plus this 1 will be plus 2. And we carry down that plus 5. So now we can do like what we just did over on the other one. Is distribute, so x times x is x cubed. X times negative 2x is negative 2x squared. X times 2 is positive 2x. And on the other one, we do 5 times x squared, so plus 5x squared. 5 times negative 2x is negative 10x. 5 times 2 is plus 10. So then when we combine these, that is how we get answer D. Moving on to the last 4 problems. We're almost done. We need to look at 17 and 18. We kind of did stuff like this already, where we had a polynomial and had to find the zeros. Here we just have to find the factors and put it in factored form. So when we look at this, we see x in each, so we can try to take the x out. All right, so we can not really rule anything out next. Now we have to look at this, try to keep the simple thing. Can we have any two numbers that add up to -2 but add up to -1? And the answer is yes. We got lucky here. So we can factor into this, which is answer C. 18, we're probably not going to be so lucky. Let's see, can we group? We get x squared, x minus 3. And then if we take a 4 out of both of these, we get x minus 3. So not too bad. We get x squared plus 4, x minus 3. So if I look at this, the only one I see x3 in is this one. But let's talk about how we get this 2i. So we want to factor that a little bit more. When we look at this, we have x squared plus 4. We need to find some number that when we multiply it together, it gives us positive 4, but adds up to 0. So we can kind of treat this like another one. Solve for x. So we get x squared equals -4. Square root both sides, so we get x equals plus or minus 2i. So if we plug it back into factored form, we get x plus 2i and x minus 2i. So that's how we got the other two. So that's why the correct answer is D. So moving on to the last one, these inequalities. So just like how the other way we have factored form here, we now need to move it into the zeros. So we have these two of our zeros. So we need to make a number line. We have -1 and -2. And we need to figure out at which point are these values for our entire expression greater than or equal to 0. So we can plug in some easy numbers here. Some numbers will not be easy. That'll be -1.5 is the only thing that I can think of that's in between that's not too bad. So if we plug in -3, we get -3 plus 1, which is negative. And then -3 plus 2, which is negative. So we get positive. Is that positive number greater than or equal to 0? Yes, it is. Next, -1.5 plus 1 is negative. -1.5 plus 2 is positive. So if we multiply that together, we get negative. Is a negative greater than or equal to 0? The answer is no. So that will not be in the solution set. And all the way to the right, we can plug in 0. So 0 plus 1 is positive. 0 plus 2 is positive, so we get a positive answer. And that is greater than or equal to 0, so that is in the solution set. So we actually have two intervals here. We have to the left of -2 and to the right of -1. So we want to write that as a interval notation. So if we did inequality, that would be x is less than -2 or x is greater than -1, but we want interval notation. So we always have to put the smaller thing to the left. So here we have -infinity on the left, -2 on the right, because technically it's bigger. And then we want to figure out, -infinity always has a parenthesis, but because we have that little dash underneath the inequality, we want the square bracket. Same thing over here, square bracket the -1, but we go all the way to the right, so positive infinity. Last question here, I decided to step it up by having 3 factors. So we have +1, -7, +6. So -7 will be right here, +1 will be right here, and 6 will be right here. So the nice number over here we can plug in is -8, 0, 2, and 7. I just like trying to choose the smallest number possible. So let's try to do this. -8 minus 1 is a negative. -8 plus 7 is still negative. -8 minus 6 is still negative. So negative times a negative times a negative is negative. We want less than 0, so that's good. That's in our solution set. Plug in 0, we get 0 minus 1 is a negative. 0 plus 7 is a positive. 0 minus 6 is a negative. So negative times a positive times a negative will give us a positive, and that is not in the solution set. Next number could be 2. So 2 minus 1 is positive. 2 plus 7 is positive, and then 2 minus 6 is negative. So altogether, that would give us a negative. Negative is less than 0, so that's in our solution set. And then let's lastly check the last interval. We have 7 minus 1 is positive, 7 plus 7 is positive, and then 7 minus 6 is positive. So altogether that would be positive, and that's not in the solution set. So we have these two intervals, which will be to the left of negative 7 and in between 1 and 6. So based on this inequality, we would have parentheses. So we have negative infinity to negative 7. And then over here we have 1 to 6. So that's how we get B. Thank you for bearing with me. If you want, you can try to do some of the other version and then check the video as well.